Hey guys, we're going to take notes on slope-intercept form. Now you're going to put these in your notebook, and we are doing something different today. As you know, we're doing some stations, and this is part of one of the station rotations that you're going to be doing. Okay, but go ahead and put today's date on it and label it slope-intercept. Well, we already know what slope is. Okay, we talked about slope the other day, and actually last night, and it's rise over run. It's the change in y over the change in x, and it's the steepness of a line. Okay, so now let's talk about intercept. And an intercept is just where the line crosses the axis. And you can have an x or a y. Okay, the general form for slope-intercept is y is equal to mx plus b. Whereas you know m stands for your slope, and now b is going to be your y-intercept. Okay, so your y-intercept is where it crosses the y-axis, and then slope is identified as m. Okay, so very basic. I want you to identify the slope and y-intercept of the following equation. Okay, well, I've written it in the general form. Y is equal to 7x plus 2 is very similar to the mx plus b. If you look up in your general form, your m is always what's with your x. It's always attached to your x. So 7 is going to be your slope. Well, b is always going to be your constant, what's outside. So 2 is going to be your y-intercept. So to identify it, or to write it, we're just going to say m is 7 and b is 2. Let's look at this one. And we are going to identify the slope and the y-intercept. My slope is what's attached to my x, so it's negative 2/3. And my b is negative 4. Be careful. And b is your y-intercept, so it crosses my y-axis at negative 4, and my slope is negative 2/3. And again, remember, slope is the change in y over change in x. So for every 2 I move on my y-axis, I move 3 on my x. Now let's go backwards. Let's say I give you the slope and the y-intercept, and I want you to write the equation of the line in slope-intercept form. Well, this is very basic. This is your m, this is your b. You've got to keep in mind that m is always attached to the x, and your b is what's constant. Okay. Now let's look at this. Now I want you to identify the slope and the y-intercept, but I'm writing it just a tad differently. 2x minus 3y is equal to 12. Okay? You cannot identify the slope and the y-intercept unless it's in slope-intercept form, which again is y is equal to mx plus b. So we have to take this equation and solve for y. Okay? This just goes back to regular equations. So I'm going to get rid of 2x by its opposite. This is a negative 3y, and I'm going to write it negative 2x plus 12. I still want y by itself, so I'm going to divide by a negative 3, and I'm dividing everything by a negative 3. So now clean it up. Negative 2 over negative 3 turns into a positive 2/3 x. 12 over negative 3 is a negative 4. Now it's in slope-intercept form, so I can identify my slope is 2/3, my y-intercept is negative 4. We'll do one more of those. Okay, again, we're identifying slope and y-intercept. You've got to write it in slope-intercept form first, which means I'm solving for y. So get rid of 4x. So 6y is equal to negative 4x plus 20. Always put the x term first. Now divide by 6. So y is equal to, I have a negative 4 6x. Always simplify your fractions. 20 over 6, again, simplify it, leave it improper. Both are divisible by 2. Now that it's in slope-intercept, I can identify my slope and my y-intercept. Okay, now you are going to proceed with your stations as to what you're supposed to do.